animate, you can record data. And yeah, you can record data. And this is something that, for instance, we have to teach this program that whenever it does distance sensor, it should just take the minimum average over a few seconds, otherwise we're going to have other things like that. And then we stop data. Now we should have somewhere here, oh yeah, we have a new file, and so basically this is the data that I just recorded, distance, I think it's in inches right now, and the timestamp in seconds, and you see that this is a very long file, but easily you can get that file into Excel, and then students can make a graph of the data they just recorded, and the exactly same program also works for the light sensor, and hopefully also for other sensors that we will do. Yes. Okay. Yes. Good. So, what do teachers actually have to do? Division. What teachers will have to do is basically download the documentation on the website, then the stuff to build one of these. Okay? The stuff to build one of these, the Arduinos themselves are between $20 and $30 depending on where you buy them. As I said, because it's an open source design, there are many vendors that produce these, and so there are many different, so you know, the price is cheap. Then the shield, the thing is that the distance sensor here itself is about $20. We're looking around if we can find cheaper ones. But for this shield here that I bought, that we built, for the shield with the light sensor, basically everything that's on that shield, that I can unplug the shield. I'm careful. Everything on that shield is about $5. And a big part of the cost is the speaker and the breadboards, because we couldn't find cheap breadboards. But so you can probably produce something like that with a light sensor like that for $2 or $3. So that makes it also useful for teachers. You can give one for the students to take home. And it's not the end of the world if you lose it. You don't want to do that with one of the things you buy commercial. And it makes it easier, you know, to buy just 20 for the entire lab, that every student has one of these things that he or she can play around with. Then you have to download the software and upload the program onto the Arduino. And what you see here, this is the Arduino programming interface. Basically, all you do, you go to File up here. You open the program that you want to load onto the Arduino. We will provide programs that say distance sensor or light sensor or light recorder, and just download it. Press another little button here that says upload to the Arduino. It's uploaded, and then the teacher can unplug the Arduino, put the shield on, and give it to the students to play with. Yes, the next thing that we plan to do is development of additional sensors. As we've seen, we need to work a little bit on software for the distance sensor to make, because we can certainly fix some of the noise and error measurement issues with the distance sensor here. And also, we first want to develop short activities that we can do with students that come for an afternoon or for an evening to Yerkes, especially if the weather's not that nice. One idea that we have actually is to make a small as mount with just 2 servos, and then the teachers can learn how to program that. The students can learn how to program that with the Arduino, and maybe just add a little telescope. Or one of our interns decided to buy big, strong servos, so maybe we can just attach, if we balance things out, we can attach a Galileoscope to it, something like that. Once we have that, to work with the Yerkes to develop and test lesson plans for classroom and education. I mean, the nice thing about this is really that this is something that engaged students can easily tell their parents, look, please buy me one of these for my birthday or for Christmas. The things don't break the bank. And the other thing is that these are extremely rugged. I mean, internally this thing has safety diodes such that if by accident I've never done it, but I heard somewhere that you can touch it, you know, if you put it on a metal surface, it should survive. It should not internally short itself and kill itself. So it's a very rugged and it's also extremely versatile design. And then, of course, other applications are after-school activities, or the goal for us is to see how can we use that in the classroom during school hours. Any questions? Yes?
Can you, I thought at one point you mentioned you might be able to write Python code, have it compile with C code?
Actually, the Arduino itself, and you can see that here. This is the language in which you program the Arduino, and it's C. But basically, I mean, we have Samantha learned it just by looking at a few programs like that. Learned, and okay, Samantha, you have to program Python. Samantha is one of our interns. So for people with a little bit of programming experience, it's not a problem. If you've never programmed before, it's possible to learn as well. I mean, especially that there are so many hobbyists that use these. Tells me that you don't need a degree to play with them. Yes. And the other thing is actually the program that I showed you before, the one that does the curve. That was programmed in Python, and that's also one that one of our students did. I mean, that's independent of the Arduino, because through the USB cable, the data connection just comes in the computer, and any language can pick up the data once it's inside the computer. The other question?
Yeah. What's the benefit of over, like you can buy sensors to use in the classroom, turn your next profile, cheap or rugged. How is this, what's the advantage?
Rugged, yes. Cheap, no. Mostly price. Yeah. Second, also adaptability, and say with Vernier. I want to run a certain filter over my data. Like in the display. Vernier doesn't provide that. I can't do it. Basically the ability to extend it yourself, or the possibility to extend it yourself and just build things yourself. And if the tool doesn't fit you re-engineer the tool, which is no problem, which you cannot do with something commercial. But it's also mostly price, as I said. I mean, this setup, $30. The same setup with Vernier, about $200. So, yeah.
Well, we've also talked about, Marc helps me with programming with my kids, and we talked about if you were changing from one probe to another, having the kids make that change by changing something small within, right?
Different shield, yeah.
So that way they'd understand what they were changing, because now they're measuring temperature, now they're measuring distance, or now they're measuring distance in meters versus feet. And so they would understand within that program what they were changing to make it happen. And for my eyes, lower level kids, and then if something's a black box like their probe, they have no clue what it is.
And that this may be an argument to actually not do shields, but just do the breadboard. Which the thing is, it takes students longer to put this together. So if you have a curriculum you need to go through, you may not want to do everything like this. But yeah. No, but that's yeah. Yes.
That the graphing software that you had, does that come down? Is that something you download? Is it part of the software?
The thing that you just saw on the screen?
Yeah.
That's a Python program that Grant, one of our interns, programmed. Where I'm working with another intern that will be with us next year. He's working with Pi2exe to convert these Python programs that Grant wrote into exe files. So basically, those will be Windows executable, or on the Mac executable that you download, and there you go. But just because we also provide the source code, or it's also possible for people just to extend it and write their own filtering or other algorithms into it. Yes.
And these would maybe particularly great for developing nations, non-industrialized nations who want to do this, like a Berthoud or science budget for a year, for their but I can imagine, there's movement of $100 laptops, and if we can keep this under $20, everything. I think that could be really cool for elementary school children in Africa, China, India.
I mean, the thing is, you can buy Arduino kits. I mean, the microprocessor itself that you have to solder by yourself. This one I bought it assembled. I was lazy. I bought this assembled. Everything came like this is now. But you can buy kits, put it together yourself for about $12. So really, if you're willing to, or have people that can do the work, it's really this can be very cheap. Yes. Yes.
Yeah, we're also thinking about building our own little sensors for inside the observatory. Isn't doable. It isn't doable. Those kinds of things that could cost a lot of money.
Frank telescope pointing east.
Feedback to their phone.
If that was me, then I call Frank.
So basically, also actually the setup that we now have for the 41-inch, the engineer that set this up, he also uses Arduinos for opening and closing his dome. He has a setup that's a little bit more expensive, but he uses an Arduino and then puts shields of his own design on them, and then to test if the door open or not, and to have these shields automatically connect to the computer that's directing the telescope. And so, but the thing is, we're hoping that this is a project that students could do. Just use a distance sensor and an Arduino, and have the student build that into the telescope control system, because it's a simple system to learn. So we'll see if Alex can do that. Yeah.
I was just looking at the vernier system, and to buy the basic system, it does have 6 possible outputs that you can put in. It's going for $329.
Yeah.
$329. I looked up
but that's with
Arduino
sensors.
That's with no sensors. That's just the body itself.
This one is really easy data logging, RED, and I think those are cheaper than the Berthoud.
I mean, the Berthoud guys are really nice guys, and former teachers. They've broken their budgets for teachers.
Yeah.
They really have a warm spot in my heart for them.
Yeah.
Might be interested in some collaboration, for developing rules.
Okay. Yeah.
But they're not greedy capitalists. They're nice people.
Yeah. I don't want to get them out of business. I just want more people to have fun toys with to play with, and especially students.
I was looking at the price of this. They're like $30 on makerbot.com. It's really cheap.
Yeah. But then again, the other thing that we would have to think about, especially if we have students who like, don't like to keep their hands to themselves, maybe to put this in a little box or something. But those are also available relatively cheap. Okay. Any other questions? Okay.
Thank you.
Thank you. Please stand by.